Hi everyone, my name is Sophia Vishnia and this is my Lab 3 report. So in Lab 3 we used a smartphone magnetometer to measure the magnetic field of the Earth and of a magnet. And so we measured the magnetic field on axis and off axis to the magnetometer. And the data for the on-axis measurements were used to calculate the magnetic dipole of the magnet, and that was used then to calculate the electric field, the magnetic field off-axis to the magnet in GlowScript. And so these are two equations that you can use for finding the magnetic field. So the top one is actually going to be the one used by GlowScript to calculate the magnetic field off-axis, and then the bottom one is just a convenient equation to use when you're trying to solve for the magnetic moment, mu. Okay, so first, before we could dive into the measurements, we actually had to calibrate the magnetometer. We had to first align it with the Earth's magnetic field so that it wouldn't be influencing our readings. And then we had to move the phone up and down and side to side so that we could pinpoint exactly where the magnetometer chip was. And it was right here from my device. Okay, and after we located the magnetometer chip, we could position the magnet so that it was exactly horizontally across from the magnetometer chip to obtain our on-axis magnetic field readings. And so we basically, for this part, we increased or decreased the distance between the magnet and the magnetometer to produce magnetic fields of the following strengths. And then we used that to calculate the magnetic moment of the magnet, and then plug the magnetic moment into a GlowScript equation to calculate the magnetic field, 45 degrees at a location that's 45 degrees off axis from the magnet. And so this is just the equation that GlowScript used. Okay, so for the first part, for the on-axis magnetic field measurements, these are right here. These are the distances that I obtained in meters that you needed to have between the magnet and the magnetometer to produce the following magnetic fields. And then I made a graph of this data on the right, and I used this graph to estimate the magnetic moment of the magnet. So if you remember, I used this equation right here, which includes the magnetic moment and the magnitude of the magnetic field, and I rearranged some terms and substituted 10 to the negative 7 rather for mu0 over 4 pi to get this equation. And then after taking the logs of both sides, you get this equation. And if you notice, it looks similar to the equation you have on the graph, where natural log of b net is going to be the y, ln of 2 times 10 to the negative 7 mu is going to be your intercept right here. And then negative 3 times ln of r is going to be, this term right here. You have your negative 2.8, which is like almost negative 3, and then natural log of r is the x. So then I use this slope component right here. Here's my slope, and then here's the equation for the slope in terms of mu to solve for the magnetic moment. And I got 0.27 for the magnetic. And this is my computational model. So as you can see, I've got the arrows depicting the magnetic field at a location on axis to the magnet in orange, and then at a location perpendicular to the magnet in blue, and then at 45 degrees off axis with the magnet in magenta. And over here I have the vectors that give you the magnitude and direction of all of these vectors, and I'm a little confused about how my on-axis and perpendicular vectors all look the same. I haven't really been able to figure out a reason why. but it looks like from the picture, it looks like they might all have the same magnitude and direction, but just start at different places. Okay, so obviously, my measurements weren't quite perfect, possibly because my magnetometer sensor wasn't too reliable. So actually my, even when I oriented my phone so that it would face the direction of the Earth's magnetic field, the readings for the X component, which should be 0, because the magnetometer is aligned with the magnetic field, would fluctuate a lot. They would start at 0, but then increase to something like 80. So what I had to do was zero out the magnetic field before I could record any data. And so finally, to answer the questions, if the magnetometer wasn't aligned with the Earth's magnetic field, then it would falsely increase or decrease some components of the magnet's magnetic field, because now you're also adding on the Earth's magnetic field to that. And if you had two magnets side by side, then and their dipoles were facing in the same way, then the magnetic field would be stronger, because now you're getting additive effects from the two magnets, dipoles, and magnetic fields pointing in the same direction. Okay, thank you so much.